This is the file interaction activity in Python. There are several ways to solve this problem or to run through this activity. I'm going to show you just one way for each of these different file types that we can solve this problem. As we go through this, I'm actually going to do research. I could probably do this off the top of my head, but I want to do research to help you understand that when you're going through these problems, a lot of times you're going to need to do internet research to try to figure out how to use some of these libraries and some of these APIs. I have the project open here in Visual Studio Code, and I've got the README file open. I'm going to skip Objective 1 for now. I'm going to assume that you should spend some time doing that research on your own. Go ahead and do that when you get a chance. I'm going to go down to Objective 2 and start through here, and I'm going to do some research as we go. I've already got the reports project and the folder open in Visual Studio Code, so I am on to step 1 here, or step 2 here, which is install basically the dependencies via Poetry. Poetry is like pipenv, except that it's just a different tool, a different program for managing the virtual environment. So I'm going to run this command real fast. So we'll do Poetry install. Let's take just a moment to basically create the virtual environment that we're going to be using and install all the dependencies. Now that we're up and running, we can navigate to this test file. So under the test folder, here's our test file reports _tst or tst.py. There's a lot going on here. We've got a helper method get file path. This is going to get the file path of a specific file name from this file path here, which is on my C drive. There's going to be a folder called temp, and a folder called white belt, and a folder called file interaction, and a folder called Python under that. So nested folders underneath that helps me organize my tests. I've got a test class. Within that, I've got a setup method. This class method, this setup class method, will only be called once every time I run the tests. And what this is doing is it's making sure that this directory path exists, making sure that all those folders are created there underneath the, my hard drive on the C drive. Then it's going to go to the source directory. It's going to go back 2 folders to the files directory, and it's going to grab these files. And these are the files that I showed in the first video. For each one of those files, it's going to copy from that directory to this temporary path that I've got here. And so that's all this is doing is before I run the test, before the tests actually execute, it's going to make sure those files are available to me as we run through the tests. Then I've got 4 tests, 1 for each file type. Each one of these is going to read the file contents, and then it's going to write the file contents back out. So here in the logo image, we're simply saving a copy. In the other 3 files, what we're actually doing is taking the file and breaking it out into multiple files. So that's what we've got going on for our tests. Let me get back to our README. We want to use the test methods to drive the implementation for each of these file types. And we're done when they pass. So let's run the test real fast. Poetry run py test. Try that again without the control B. These all fail as I would expect them to. So I've given you tests that fail. Our goal is to make them pass. So we can do these in any order. I'm going to actually start with, I'm going to skip the logo file for now. I'm going to start with the account balances file. So we're going to do this one first. This is, if we look at the file, this is the accounts.json file. So looking at this, the reason we're failing is we're getting an exception thrown on the read file content. So I'll go to definition here, and we'll see that here is our exception. This is exactly why we're failing. So what we need to do is we need to get this to pass. Now remember, this is a JSON file. And again, there are several ways to do this. So I'm going to need to read the file contents and return the accounts that are represented in that file. Then for each one of these, I'm going to write the file contents for that particular account. So we're reading them all, we're breaking out the records, and then we're creating a different record for each one. So to start with, let's figure out how do we read a JSON file in Python. So I'm going to go over to Grok. I recommend using AI tools for these only because it will give you code right away. You can certainly use a search engine and see what comes up either with the AI tool help there, or go to something like Stack Overflow and see if you can read through. But since I want to see some example code, I'm going to start with a tool. I'm just using Grok in this particular case. I'm going to type Python read JSON file and parse. I want to parse that record. So parsing is a matter of reading the data and then interpreting it or processing that data. So we're not just reading the contents and storing them. We actually want to make sense of what's going on. So that's what parsing is. So I'm going to hit that and let's see. Good. It's got some code and it's got some examples here. So this is exactly right. We're going to use with open and then some file path. R is for read, and that's going to create a variable. We're going to call it file. We could call it something else. And then we're going to use this JSON package inside Python, and we're going to call the load function, passing in the file from open, and that's going to give us the JSON data. And then from there, we can then run through. So here's an example record. We can use that to run through and see what's going to come back. It's going to give us back arrays and dictionaries based on whatever's stored inside the file. In this particular file, it's a single element or a single object. But in our file, we know it's an array of objects. So we're going to pull that out as array. So there's a few things going on. So now that we've got this, we can copy and paste this in. I'm not going to copy and paste. I'm just going to retype it, but you can copy and paste it in and change what you need to change. So here, let's get rid of our exception. And here we're going to read this. So with open, and we need to give it the file path. Now the file path is coming in from our argument right here. And then I need to give it a value that says, what type of open am I doing? Is it for read? Is it for write? Is it text? Is it binary? I can just do little r for a read text file. And then I need to give it a variable name. And I'll just call this file to make it easy. I could call it text file. I could call it JSON file. There's lots of different names that I could call this. I'm going to keep it easy and just call it file for now. I can always rename it later if I need to make it more specific. This with block is going to automatically close the file that was open to make sure we release the handle on the file so other applications can open the file when we're done. So the with block will automatically close that for me. Now that I've got that, I'm going to use the JSON library. So I'm going to import JSON. This is just a package inside, built into Python that comes with Python. So I'm going to pull that in, and basically this is going to give me my accounts array that's going to be inside the file. So I'll say accounts array equals json.load, and we pass the file. And this will read the file contents and give us back objects inside Python that represent the values that are in there. And in this case, it's going to be an array because the root element is an array. Each object in there is going to be stored in Python as a dictionary, and then I can pull those values out to then create my accounts. So what I want to do is I'm going to create accounts and return them from this method. So I'm going to say my accounts is a new empty list, and we'll go ahead and return accounts, which is empty, but we're going to populate that. So we'll say for each account, and let's call it account object to distinguish between the account. This is the account object in the JSON file. So for each account object in the accounts array. So each one of those curly brace objects that we've got stored in there, what I need to do is pull the values out and create an account and add it to the accounts list. So I'm going to do this in several lines of code. We know there's an ID property, so we'll say ID equals account object, and this is a dictionary. This is a Python dictionary. So I'll use the square bracket and then basically pull in the ID value here. So that will give me the value of the ID, whatever that is. And it's going to vary depending on the element. So that value is going to be different values as we go through. So we've got a name or an ID. We're going to have a name and then a starting balance. And just to make sure we're all on the same page, let me open up the code or the files themselves just so we can use it as an example. So ID, name, oh, not starting balance, balance. Glad I checked. So ID, name, and balance, these are going to get the values. So what's here inside the quotes is the name of the key value pair of the property. And this gives me the value, which would be 1 primary checking and 100 for the first one. So 1 primary checking and 100. The second time through my loop, it'll be 2 accounts receivable and 400. So then I need to create my actual account. So I'm going to create a constructor on the account class that takes the different values. And then I'm going to add that to my list and then return those. So this is all looking pretty good. We're basically parsing or peeling out data. We're pulling out the data that we want and then storing that out as an account object. Now we do need this constructor. This constructor doesn't exist. So I'm going to go to the end of line 3 and hit enter. We'll say def __ init. So init is the constructor. We need self. And then in this case, we're passing 3 values. So we'll say ID, which is a number. So this is an integer. Then we have name, which is a string, and then balance, which is a number or a float. So we'll do a decimal number there, a float. I'm doing type hints just to help me out. Now that we've got those, I'm going to hold on to those. We'll say self ID equals ID, self name equals name, and self balance equals balance. So now we've stored those values off and we've returned the object there. So if I run my test now, I'm going to make progress, but I'm still not going to pass because we're going to get to this exception here on the write file. So now I'm going to implement the write file method. Write file is going to be very similar. So if we go back to Grok here, we'll say Python write JSON file. All right, so it's advanced mode. That's kind of fun. So it's giving me some code here. We've got with open, and now we need W as write. And now we're going to use the JSON.dump method. Dump is just a word that basically means write out or send the contents to a file. So we're going to dump the data to the file that we're talking about. We can specify the indent. I'm not going to worry about the indent. I'm not worried about that. But it's pretty straightforward in terms of what we're doing. And that the data itself is going to be whatever we're looking for. So we're creating, in this case, a dictionary. What we want to do is do the same thing. We're going to create a dictionary that represents the values we're going to store back out. So again, you can copy and paste this down if you want. I'm going to type it out directly. We're going to get rid of this and say with open. And again, file path is coming in. So it's the name of our argument here. And this time I'm going to pass W because we're opening it for write. I'm also going to call this file. Again, I could make it more specific, but I'm going to leave it generic for now. Now that we're opening up the file path, we need to dump to it. So we'll say JSON.dump. And the first thing it wants is the object we're dumping, and the second thing it wants is the file to which we're dumping. So the object is going to be a dictionary, a Python dictionary. And I'm going to go and pass file in, and now we need to populate our object. Now I'm going to do this real quick. I'm going to do this as a separate object so we can kind of see what the code looks like. So let's call this file contents object. Let's call it account object. So we'll recreate the account object. So there's our dictionary object, and we're going to pass this into our dump method. And here what we need to do is we need to give this dictionary the values that it needs. And so we're going to rehydrate what we pulled out here. So we're going to say it has an ID property of something, and the ID happens to be self.id. It's going to have a name property that's self.name, and a balance property of self.balance. So these values and these values are the same, and then the ID we pulled out and self.id where we stored it are going to be the same as well. So we're reconstituting the object, we're dumping it straight out, and then saving it back out to the file. So let's check our test to see if we've made progress. Sure enough, we have one passing, so that test is working. So let's move on to the next test. So we've got customer, we've got logo, we've got transaction. I'm going to do customer next. Let me head back to the test and looking down at customer. This is the TXT. Remember, it's the CSV file. So we're going to be parsing out CSV records from this file. So again, let's open up that file so we can see what it looks like. So here's our record. We've got our header row, which we don't want to use, and then we've got the different values. So once again, let's do our search here. So I'm going to change the search in Grok, and we'll say Python read CSV file and parse values. Apparently it wants me to sign up. All right, we're going to switch over to ChatGPT. So we'll say again, Python read CSV file and parse values. Perfect, it's giving us our code. This is going to look very similar. We're still saying with open data CSV, and now it's going to say new line. So we're going to import this CSV package as a part of it, and we're going to use the reader to read the records out. This new line is optional. I'm going to actually leave it off. We're going to simply read that through. Once we get that, you'll notice that it's saying headers equals next read, so it's reading that first record. We can do something with that if we want. We're actually going to skip the headers row, so I'm just going to call next, and then we're going to iterate through the rest of them with using for row in reader. So very, very similar to what we've got here. So let's head back into our code. So customers, we need to implement the read file content. So again, we're going to import CSV. Let's head back to our read customer read file contents. So with open, given the file path, and this is again going to be a read as file. We'll say CSV reader, given the file. And this is going to give us our CSV record. So this is going to be, in this case, they called it reader. We call it CSV reader. And once like I said before, we're going to skip the header row. So we'll simply call next CSV reader to skip that header row. If there was no header row, if this first line were deleted, we would not want to skip the first row because the first row actually has data. But in our file, the first row is header rows and it's not an actual value. So we're going to skip that row. That's why we're saying next CSV reader. So we're simply skipping past that first record. Then we're going to run through the different rows. For row in CSV reader, we need to do something with these values. And here, what we're effectively going to do is pull back the values themselves for each one of those different elements. So, and I can't remember if, I believe, yeah, this is a list of, okay, string. So the indexer for this particular list is going to be an integer array. It's just a regular list, and then it has the string values that are coming back out of it. So again, looking back at our file, we've got ID, name, and starting balance. We'll say ID equals row 0, so the first element. Name equals row 1, and starting balance equals row 2. So we're going to peel those values out of the array. Once we have those, we need to create our list of customers. So just like we did before, we'll say customers equals new list. Down below, we'll say customer equals, we'll call a new customer, we'll give it the ID, name, and starting balance. And we'll add that to our customers list. And then finally, we return customers. So very similar to what we did with the account class, except in this case, we're using CSV to pull these values out rather than JSON. Once we have those, again, we need our constructors. So let's go and create that. And this is going to give us an ID, a name, and a starting balance. I'm not going to do type hints here since they're all strings. We could do type conversion to get the ID to an integer and the starting balance to a float. I'm not going to do that. I'm going to leave these all as any because we're not terribly worried about these particular values. So we'll simply say self.id equals ID, self.name equals name, and self.starting balance equals starting balance. Now that we've held on to those, similarly, if I run the test, I have a new error, which is the write file. Let's go and implement this. As you can imagine, it's going to be very, very similar. So let's do Python CSV, let's say write CSV file. So this is effectively creating an array of arrays. So each row is going to be an array of the strings, and then the data is going to be the array of those arrays. We'll open it for write, just like we did with the other file, and then we'll go to CSV writer. That'll give us a writer object, and then we simply write those rows. When we're done, it'll automatically close it. So we're going to do, again, very, very similarly. I'm going to copy and paste this one this time, just again, so it's closer to what you might be doing on your code. So with open, now we're going to change this to be the file path coming in. Mode is write. I like double quotes. We'll have our writer, and I'm going to rename this to CSV writer. That is csv.writer given the file, and then we will say CSV writer, write rows, data. Now we need to create our data. So let's go and do that. We'll say data equals, and again, it's an array of arrays. And we're only going to have one record here, so it'll be self.id, self.name, self.starting balance. So there's our data. This is the single row that we're going to be writing out along with the different values. Now I could do the headers as well, and I do want to do that. So let's do a header row. And so these will just be the hard strings that we've got here. And I'm going to actually copy these. Well, we'll just retype it. ID, name, and starting balance. So ID, name, and starting balance. So we've got our header row, and then we've got our single row for this object that'll be written out as the data itself. So let's save, rerun our test, and see if we've made progress. Sure enough, we have 2 passing. We're making progress. Let's move on to the next exercise, or the next test, rather. So looking back, we have, the next one is going to be transactions. This is going to be the XML file. So we're now going to read through these transactions and again, parse them back out. Let me open up the transactions file so we can see what that looks like. So here's our transactions element. Each one of these elements is going to have an ID attribute and then 2 child elements for the date and the amount. So we want to pull those back out. So let's run through that real fast. So as we did before, I'm going to go back to our search here, and I'm going to say Python read XML file and parse. I'm going to parse the values out. All right, it wants me to sign up there. So we're going to switch over to good old handy dandy Google. Just run it there. So we'll say Python read XML file and parse. All right, so this is going to be using the element tree object that comes in, the class that comes in from the XML package as a part of Python. Once we do that, we'll simply say tree equals et.parse. That's going to give us the element tree. We sometimes call this a document in other languages. Then we get the root element. The root element is going to be the transactions element. So that's the root element. Once we have that, we can start doing things with the attribute, with .attrib, and then child, we can iterate through the children, the child objects, and then we can use a method called find to get specific values out of that. Find and find all to get the text. So this is basically the different values that we want. So let's go and start implementing our code here. So once again, we're going to import, and we'll simply import xml.etree.elementtree. And I'm going to alias this as element tree. Google basically aliased it as ET. I like spelling things out, so I'm going to name this as element tree so I can use element tree down below. So inside our transaction class in the read file contents, we're going to, again, going back, we're going to call et.parse. So we'll say element tree equals element tree.parse. So element tree little is my variable, big element tree is the class. We're going to parse, and in this case, it wants the source. And so we're going to simply give it the file path. So now that we've got our element tree, we want to get our root element. So this is the transactions element. This is going to be the root. Get root. That will get us the root element. Now that we've got that element, we're going to iterate over the child elements underneath. So again, as we did before, we'll say transactions to hold them. We'll return the transactions. And we're going to iterate over the child transaction elements. So for each transaction element and transactions element, so the singular and the plural, so for each one of those, we need to pull out values. So we need to get the ID attribute values, the ID, and we need to get the date and amount elements values as the date and amount. So we'll say ID equals from the transaction element, transaction singular. We'll go to the attrib. An attrib is basically a collection, or in this case, it's a dictionary. So I'm going to give it ID to represent the ID attribute so that we get the value of that. So there's the ID. And then the next is going to be date. So date is going to be from the transactions element. We will find the date element. This is here. And then from that, we want the text of that element. The text is inside the opening and closing tags. That's the text that we're looking for. So that's the date. And then similarly, amount is going to be almost identical. We'll say transaction element.find amount.text. Now that we've got those, similarly to what we did before, we're going to create a transaction object. We're going to give it the ID, the date, and the amount. And then we will add that to our list, just like we did before. So a lot of the same kind of things. Here we need to create a constructor, just as we did in the other two classes. ID, date, and amount. And similarly, since these are all coming into strings, I'm not going to be doing any parsing. I'm not going to do type hints. I'm simply going to store everything off for now. Once again, I could run the test and I'm going to get a failure, and I would encourage you to do so. You should get this failure here, where now we're on the write file problem. So here we need to write that back out. So once again, let's do Python write XML file. And it's also going to use the element tree class again. And it's going to basically call the static element method with the name of the root element that we're going to be creating. And then underneath, we're going to create sub elements from that root and add those in. So this is going to be a little bit more complicated because we're dealing with, effectively we're dealing with the XML model, and a lot of this is the built-in XML API that's been a standard for over 20 years now. So I'm gonna pull this in kind of piecemeal. So again, we'll say element tree equals element tree.element. And our element is going to be a transaction element. This is the name that we're going to give it. And this is going to map what we're doing here. So again, we're creating a single file with a single transaction element. We're not doing a collection of these for each of these files. So there's our transaction element. Next, we need to create our child elements and our attributes. So element tree, attrib ID, this is going to be self.id. And then our child attributes, we're going to have one for date and one for amount. So we'll say date element equals element tree dot sub element. Now the sub element wants the parent element, so that's going to be the root element. That's going to be our element tree. And let me rename this so it makes a little more sense. We'll actually call this the transaction element. So we're going to give it the transaction element, and then we also need to give it the name of the element that we're creating. So this is going to be the date. So transaction element is the parent, date is the name of this element, and then we need to set the text. Oh, and I see I set the attribute incorrectly before, so I'll fix that. So we'll say the element.text, date element.text equals self.date. And then on this line here, I need to change this. So transaction element set, and we're going to say ID, and then it wants the value, self.id. So this line was incorrect. We need it to be the set method, so we set the attribute. So now that we've got that first child, we need to do the second child. We do have a second child, which is the amount element. So we'll say amount element equals element tree, sub element. Also, the parent is the transaction element. The name of this one is amount. And we'll say amount element dot text equals self dot amount. Once we're done with all of that, now we've got our tree. And we're going to create a tree object, and then we write out to the file itself. And I'm going to again do the shorthand version of this. So now that we've got our object, we'll say element tree equals element tree dot element tree. This wants the root element itself, so we're going to pass the transaction element. That is the root element. That's the object that we're going to actually write out. And then finally we say element tree dot write. We want to give it the file path, which is again coming in. And then it's got the encoding and the XML declaration. I'm going to skip these and just assume that the defaults are going to be good enough. So we'll save that. Let me rerun our test to see if we made progress. Sure enough, we have 3 passing. We're looking pretty good. The last test that we need to run is for the image file. So this is our logo image. So let's go and go to the contents here. Here we're simply reading. And again, you can do an internet search. I'm going to do this one very quickly. So what we're going to do is, again, with open, given the file path. Now here what we're doing is we're reading it as a binary file. So I'm going to give it B so that we can read it as a binary file instead of a text file. I'm going to do BR for reading the binary file. So we'll say it's file, and we'll say the data or the file contents equals file.read. And that gives us, you'll notice that it gives us the bytes, the byte array that's coming back out of it. And we'll simply return a new logo image. So we'll simply return logo image with the file contents. So once again, we're going to need to create a constructor to hold on to those values. Self.fileContents equals file contents. As we did before, you can run it. You can see the failure. The saved copy is not working, so we need to do the same thing. So we're going to say with open file path, this is going to be a write binary, so BW as file. And we're going to call file.write, and it wants the readable buffer, which is going to be self.fileContents. So this one's the simplest because we're not parsing data. Image files, there's nothing in an image file that you can really parse. We're copying the whole file as it is. We're effectively making a copy. So this one's kind of the fastest one. Let's rerun our tests. Sure enough, 4 passed. That concludes that. So hopefully this all makes sense in terms of the different file types. This is, again, one way to solve this problem. There are lots of other packages, lots of other libraries, lots of other ways to use these packages and libraries I use. This is just one particular way to use it. I would encourage you to do some more internet searching, use some more AI tools, see if you can come up with some new APIs and new ways of doing this exercise. But that effectively concludes the file interaction activity in Python.